Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 7F assignment. Okay, first one, number one, for each data set, obtain the power model which best fits the data. Okay, so when we're doing these, you want to enter these into your TI-84 so that we can figure out what this thing is. Okay, so here's what you want to do. Open up your, turn on your TI-84, go into Stat, and then we're going to edit the data so we can put our data in there. Okay, so I have already went through and put all the data in there. So here's all of our correct data. This is our X and this is our Y. And now what we want to do is we want to do Stat, and then we're going to go over to Calculate, and we're going to go down past number 9. Come on, you can get there. And we want to go to Power Reg. So we are used to doing linear regressions from earlier material that we've been doing here, but now we're going to do a power regression instead of a linear regression. So this is basically saying it's going to be some kind of like curvy graph going on here. Okay, so we got power regression going on here. We push enter. X is in list 1. That's what we did. Y is in list 2. Make sure frequency list is cleared out. And then we don't need to necessarily store the regression equation. I'm not sure exactly what that's about, but then we hit calculate, power regression, and out it spits. So we've got y equals a times x to the b power. Now, first thing we kind of want to look at is our r value. Look, 0.999. This is like really, really close to a perfect power regression. Okay, so our power regression says it's going to be y equals a, which is 0.602. So we've got y equals 0.602. And it's going to be x to the, and here's the other glorious part of this, 3.9998. So this is to the 4th power, because these aren't going to normally be to any kind of weird decimal powers. It's just going to be to, like, this is going to find us, like, you know, 1st power, 2nd power, 3rd power, 4th power, 5th power, so forth and so on. These are going to normally be integers here. So that is going to be x to the 4th, and there is our equation here. Okay, y equals 0.602 x to the 4th would be the power model that best fits this data. So this is a quartic. Okay. All right, number 2, Zach never remembers to charge his phone until the battery has completely run out. This table shows the percentage of charge his phone receives when it's charged for different times. Blah, 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 blah. What type of variation would you expect between C and T? Explain your answer. So the time and in minutes to the percentage of charge. So I don't know. I mean, I'd kind of expect it to be a linear variation, right? Like the more time you plug it in, the higher the percentage of charge would be hopefully a fairly natural guess. Okay, so we'd officially call that a direct variation. Okay, explain your answer. Yeah, direct variation, because again you would think that like for every 8 minutes I'm going to get 10% charge out of it, right? So it should be pretty close to a direct variation. Now, would these numbers be exact? Maybe, but probably not. Okay. Find the power model which best fits the data. So back to our graphing calculator, right? And we're going to go into Stat, and we're going to edit our data, and we'll put all that stuff in here. Okay, so here's all of our data. All right, so now we're going to go into Stat, Calculate, and we're going to go down to, I think it's like the 11th thing down here, power regression. So it's actually A. Okay, so we push power regression. Our X is in list 1, our Y is in list 2. The frequency list is clear. This is clear. Calculate, and we get, it's a very close power regression where our power is just 1, which means linear, right? So it's going to be 1.25 x to the 1st. So our power model would be y equals 1.25 x to the 1st, which simply will just be y equals 1.25 x. Okay. And so really what this means is for every minute, you should get 1.25% of your charge. Okay. All right. So for part C, so that was B. For part C, estimate the percentage change of the phone after 56 minutes. So let's use our little formula here. So percentage charge. So really this Y should be a C, 1.25, and then this should be a T. Instead of that, this is our better actual formula here. So our charge should equal 1.25 after 56 minutes. So just plug 56 in for our X, and we can calculate that. We'll do 1.25 times 56 minutes, and we should be at about, we should get about 70% charge. Okay, for C. And then for D, for what values of T is it reasonable to apply this model? Explain your answer. So, T would have to be greater than or equal to 0. You can't have negative time, right? And then really this model here is going to stop once we get to 100%, right? So let's do this. So we would want to do charge. We know, so we got charge equals 1.25x, right? So we're going to stop when we get to 100% charge, right? 1.25x. So divide both sides by 1.25, and we would want to unplug it after we get to 100%. So 100 divided by 1.25 gives us 80 minutes. Okay, so T should be more than or equal to 0, but less than or equal to 80. That's when this formula here will actually work, because you're not going to get up above, you're not going to get up above 100%. Okay? Because it'd be great to have 120% of battery if you just keep plugging it in, but of course that does not work. Okay. Number 5, when a car turns a corner, its turning radius depends on its speed. Obtain the variation model which best fits the data. So back to our graphing calculator. Stat. Come on, stat. There it is. We're going to edit. And then we're going to put all this data in. This is going to be my X, and this is, well, so they're going to be the X and the Y, but this is going to be list 1 and list 2. On this thing, okay? Okay, so here's all of our data all entered in here. Okay, so to figure out our variation model which best fits the data, let's go back into stat. We're going to go over to calculate. And we're going to do a power regression. Okay, list 1, list 2, frequency list. These two things need to be clear. And then calculate. And it tells us this is a really good, strong model. And then our, wow, okay, so our power here is going to be 2.292, or basically like about 2.3. And our A is going to be 0.0196. That's kind of an interesting one. So we'll just write that in there. Y equals 0.0, I think it was 0.019. And since that's really only two significant figures, let's go to the next one, 7, right? And then we got x to the 2.29 power. Okay, so this is the variation model that best fits the data according to our calculator, right? B, estimate the turning radius for a car traveling at 10 meters per second. So that is going to be our list 2, which is really our Y, and that's our X, right? So if it's traveling at 10 meters, oh, sorry, that's our speed. So that's going to go in for our X right here, right? So we get Y equals 0.0197 times 10 to the 2.29 power, right? So we'd want to calculate that out. Second quit. And we get 0.0197 parentheses 10 to the 2.29 power, right? And we get 3.84 is what I'm looking at here. So 3.84 meters turning radius. Okay. So like this one, you're traveling faster. That's meters per second. So you're traveling faster. It's going to have a wider turning radius because you're going faster. All right. Okay. I'm just added C on here because I wanted to look at this because this will be a tricky little calculator thing to try out here. So I want to make sure that you get to take a look at this as well. So for part C, estimate the speed of the car if its turning radius is 4. So 4 is going to go in for the Y. So we do 4 equals 0.0197 x to the 2.29, right? So we'd want to get x by itself as soon as we can. So we divide both sides by 0.0197. 0.0197. Those go away, and we get x to the 2.29 is going to equal, let's see, we'll do 4 divided by 0.0197, right? And we get 203.045, right? And then now to get the x by itself, we actually have to take the 2.29 root of both sides. 2.29, because that will take care of that, and we will get that x equals. So in order to do that on your graphing calculator, or you can do it also on a scientific calculator, on the TI-84s, you're going to want to put your power, your root in first, 2.29, and then we'll do math, and then we're going to do this x root down here, number 5. Okay, so that's going to put the 2.29 in for the root, which is what we wanted. Then we want to put this in for the answer. So we do second answer and do enter, and we get 10.18. So x is going to be 10.18, and that is meters per second. Meters per second is your speed, 10.18 meters per second. Okay. Okay, so that's all we have for this section here. If you have any further questions on any of this that we've done here or any other part of the assignment, please feel free to ask. Thanks.